Hi everyone and welcome to Geometry Lesson 3. Today we're going to be learning about different types of triangles, or revising that. So the goal for today's lesson is for you to be able to solve problems involving angle sums of triangles, quadrilaterals and polygons, and also to use the exterior angle properties of a triangle. Exercise 4.3 in the Year 11 preliminary textbook. Okay, so you should know the different kinds of triangles in terms of their sides and angles, and basically they're listed here for you. Okay, so you've learnt most of these things in Year 7 and 8, looking at different types of triangles. So I'll let you read and kind of remember that. And then there are some important triangle relationships that we're going to be revising. So the exterior angle of a triangle rule. In a nutshell, that one says that basically if you have an angle here on the outside, that equals to the two angles on the inside added together, and that's this rule here. We know angle sum of a triangle is 180 degrees. We know in an isosceles triangles, we have the two angles opposite the equal sides the same, so P equals Q. And we know in an equilateral triangles, the angles are all equal to 60. So in this course you need to know proofs of things, and one of the proofs that's good for you to know is why the angle sum of a triangle is 180 degrees. So it's really important that you have a look at this proof, that you have a read through it, and that you understand it. If not, you need to ask me when I see you next. Same with the exterior angle of a triangle rule. So why is that rule true? And there's a proof of that here. Again, these proofs are just from your textbook, and I've put them in here for you to have a look at and see if you can understand after reading them. Okay, so it is important that you know them, but for the purposes of this video, we won't spend time going through it now. If you read it and you're not sure, please do ask me. Okay, so the sorts of questions we're going to be revising are you needing to find missing angles, missing pronumerals, giving reasons in triangles. Okay, so if we look at this first one here in question A, basically I can just start off straight away and say that angle E is equal to 68 degrees. And the reason for that is they're equal angles, opposite equal sides. So you're going to write that in your reason. That's the first thing. And so if I know this angle here is now 68 degrees, then I can work out angle F using the angle sum of a triangle rule. So I can basically write down that F plus 2 lots of 68 equals to 180. And that will give me F being equal to 44 degrees when you subtract the 2 lots of 68 from both sides. Okay, so that's question A. In question B, you'll notice there's a right angle here on the outside. So that's important to take note of. And you'll notice that's then the exterior angle. So what we can do is we can actually say that N plus 43 degrees is equal to 90 degrees. And that's using the exterior angle of a triangle rule. So exterior angle of a triangle equals the sum of the two interior opposite angles. So you need to write that reason out in full. It is a bit of a task, but you get used to doing it and then you improve your speed on it. So subtracting 43 from both sides on that one, you get N is equal to 47 degrees. Okay, so we've done 2 of those questions so far, and you can see how we've written the reasoning on the right next to what we've used. Okay, question C is asking us to work out what angle R is there. Now I know that this is an isosceles triangle because the little markings on the side show that. So that tells me that these interior angles are all 60 degrees because that's basically a equilateral triangle. So I can say in this one that r plus 60 degrees equals to 180 degrees. And then I need to write why I can say that. So in my brackets I'm going to say firstly equal angles in an equilateral triangle. And I also will need to say, because I've let it add to 180, is they are actually adjacent supplementary angles. So you need to make sure that you're writing your reason down. Awesome, so subtracting the 60 from both sides, r is 120 degrees. Ask yourself, does it make sense that this angle here is 120 degrees? Well, I think so, because it's actually an obtuse angle. Brilliant. Okay, moving on, we're going to be looking at 2 more questions in this section and then have a look at some of the harder questions. So question D, is asked me to work out the value of s. So they want me to work out this here. To be able to do that, I've got to jump through a few hoops. Okay, so first of all, what I do know is that they want me to find s. But I also know a couple of other things. For example, I know this angle in here is 39 degrees because these two here are actually vertically opposite angles. And I can also work out this angle here because that's on a straight line. So I can work out angle BDC, and that will help me to find s. Okay, it's not the only way. Perhaps you can see another way, but this is the way I'm going to be doing it. So writing this down, I'm going to write down that angle DBC, that is the one highlighted in yellow, is 39 degrees. And I'm going to write that my reason for that is vertically opposite angles are equal. That's the first thing. The second thing is, now I'm going to say that angle BDC plus 97 degrees equals 180 degrees. And my reason for that is adjacent supplementary angles. And that basically means that angles on a straight line add to 180. So angle BDC, when you do 180 minus 97 is 83 degrees. So this one in here is now 83 degrees, and that's going to allow me to work out s. So I'm basically going to go now s plus 83 plus 39 equals to 180 degrees. I'm going to be writing in my brackets that the angle sum of a triangle is 180 degrees as my reason. And when I subtract the 83 and 39 from 180, I get 58 degrees. Okay, so clearly showing all your steps, equal signs aligned, reasons in your brackets in full. Fantastic. Okay. Have a look at question E. So in question E, you'll notice I'm asked to find 3 pronumerals. I'm asked to find x, I'm asked to find z, which is this tiny little angle in here, that one, and I'm asked to find y. So let's take this one step at a time. First of all, I can start off by saying x is equal to 60 degrees. How do I know that? Well, they're showing me it's an equilateral triangle. So I'm going to write down equal angle in an equilateral triangle. Okay. So I know x is 60. Then I'm asked to find y, and I'm asked to find z. Okay, so if x is 60, that also tells me this is 60 here because it's an equilateral triangle. So I'm going to write down that y plus 60 equals 180 degrees. And that will then mean that y is 120 degrees. And my reason for that is adjacent supplementary angles. Remember, adjacent just means next to. So what you're really saying is those two angles next to each other on that straight line add up to 180. Okay, and my final step then, because if y is 120, is to work out z by using angle sum of a triangle. So I'd be going z plus 120 plus 31 equals 180. Sorry, I ran out of room there. And I'm going to write my reason, angle sum of a triangle equals 180. And then when you subtract 120 and 31 from 180, you get 29 degrees. Okay, so just write your reason in brackets for that one. I ran out of room, but you guys make sure you write it down. Okay, question 2 is very similar to question 1, but it's a little bit more complex. Okay, and you can see that the pictures in that one are showing a lot of different things. Okay, so in this section of work, you're asked to find the value of missing pronumerals, but also you'll notice you have to use your parallel line theorems because they've given you parallel lines. So let's have a look firstly at question A. So in question A, you can see that basically there's an F shape here. Okay, and inside that F shape, you have this angle and this angle. And an F-shape angle is a corresponding angle. So for part A, you're going to write down that x plus 57 degrees is equal to 88 degrees. And your reason is going to be corresponding angles on parallel lines are equal. And then you're going to subtract the 57 from both sides, and you're going to get 31 degrees. So that's part A. So in all of these, you have to kind of look carefully and have a look. What parallel line theorems can I use? What can I be given to solve that? Fantastic. Okay, the last question we're going to look at, so you guys need to try the rest of those either in your workbook or in this blank page here, on this blank page, and then ask me any questions you have in class, okay? Make sure you're setting out your reasoning carefully though. Okay, in the last couple of minutes we're going to do this question here, and it says in triangle BCD, below BC is equal to BD. So what I can do on my picture is put little markings in like that, and they want me to prove that the line BC is parallel to DE. So we're looking at the line BC here being parallel to DE. That's our aim, to show that they're parallel. And so I've got my little markings in here like that from before. And what I want to do now is I want to, that little marking shouldn't be there near the D, can't get it to move at the moment, so we won't worry about that. So I need to prove that. So the first thing I need to do is I need to kind of figure out some missing angles. Okay, so the first thing I can see is if those two are equal, then this must be 46 in this bottom corner here. And I'm going to write that down. So I'm going to write down angle BDC equals 46 degrees. And the reason is equal angles opposite equal sides. Then I'm going to say that angle CBD plus 2 lots of 46 degrees equals 180. My reason for that, which you need to write down, is angle sum of a triangle equals 180. You guys write it out in full. I've just run out of room. And that means that angle CBD equals 88 degrees. Now, since